I talk about the definite integral and the also upper and lower Riemann sums, okay? And let me continue with this topic, but I want to remind some formulas about it, okay? And what was that? The first, the definite integral. You can also find these notes from the yesterday's lecture notes, okay? And we have a comma b closed interval, and on this interval f function is continuous, okay? And we have p set which includes x0, x1, x2, it goes like that, and the xn. That means we have n plus one different point on the a comma b closed interval, and also a equals to x0 and the less than x1, less than x2, it goes on like that, and the xn which is equal to b, okay? And the what's that? P was, okay, called a partition of a comma b, and the upper and lower Riemann sums lower Riemann sums symbol LF comma P, okay, and this P is capital letter, and the U F comma P means upper Riemann sums, okay? And let me give these formulas. It equals to f of L1. That means the lower value of that interval. Which interval? It's the interval is x1 comma x2, okay? On this interval, okay, lower value will be L1 and the upper value also will be U1, okay? And the del x1 plus f of L2 times delta x2 plus it goes on like that, and the f of Ln times delta xn, right? And then you can show this equation by the notation, summation notation, which is the sigma notation, as you know, and the I starts from 1 to the n, f of L sub I times delta x sub I, right? And similarly, you can write the upper summation formulas, u f comma capital P, it equals to f of, okay, and I'm sorry, that was not v, it was u, u1 times delta x1 plus f of u2 times delta x2 plus it goes like that, and the f of un times delta xn, and the sigma notation, sigma I starts from 1 to the n, f of u I times delta xi, right? And let me give you an example to understand this lower and upper Riemann sums, okay? For example, f of x equals to 1 over x, right? And the 1 comma 2 close interval. We know that this function is continuous on this interval, okay? Because of this function is a polynomial function, and the polynomial functions are continuous on the whole real line. Don't forget it, okay? And after that, let me take the x0 equals to 1, x1 equals to, okay, 5 over 4, x2 equals to, okay, 3 over 2, x3 equals to, okay, 7 over 4, and the x4 equals to 2, okay? That means now we have 5 different points, okay? And on the real line, let's show it, okay? And this point is 1, and this point is 2, okay? And this point is 3 over 2, and this point is 5 over 4, and this point is 7 over 4. Okay, now as you see, we have 4 equal intervals, okay? And as you see, what can we say? 1 over xi, okay, to do 1 over x I minus 1, okay? And to understand, okay, lower Riemann sum, okay, we must know which value is bigger than the other, okay? And firstly, okay, we know that the delta x values, delta xi values, we know that delta xi values for this function is 1 over 4, okay? As you see, how did we found? 5 over 4 minus 1, it's equal to 1 over 4, okay? And which value is lower and which value is upper value, okay? Firstly, let me write the delta x, okay, times, okay, and let me write the sigma notation, and after that understand it, it will be clearly, okay? I starts from 1 to the 4, okay, and the f of, okay, Li times delta xi, right? And what's that? Let me write it. Firstly, which value is bigger and which value is smaller, okay? Let me understand it, okay? And the 5 over 4, and it will be 4 over 5. And as you see, okay, the right hand side is always, okay, lower than the left hand side value, okay? That means, okay, look at these two values, okay? Which one is lower value on the f of x? That means, okay, f of x1 is, okay, lower value. And they look at this green values, okay, which one is lower? Okay, of course f of 3 over 2 is lower value. So let me write the functions, okay, and extract it, okay, and what will it be? F of, okay, and the L1, the L1 will be, okay, let me write it, f of L1 times delta x1, okay, and the plus f of L2 times delta x2, okay, and the plus f of L3 times delta x3 plus f of L4 times delta x4, okay, and this will be f of, okay, and the 5 over 4 times delta x1. What is delta x1? We said that delta x1 is 1 over 4, okay, because of we have equal intervals, okay, so all of the delta xi's will be 1 over 4, okay, and the 1 over 4 plus f of L2, it will be f of 3 over 2 times 1 over 4 plus f of 7 over 4 times, okay, 1 over 4 plus f of 2 times, okay, 1 over 4. Okay, because of the 1 over x function is, okay, increasing function, so always right value will be smaller than the left value, okay, don't forget. And after that, as you see, we have 1 over 4, so we can take the 1 over 4 multiplication, and after that f of 5 over 4 plus f of 3 over 2 plus f of 7 over 4 plus f of 2, right? And after that 1 over 4 times f of 5 over 4. It will be 1 over 5 over 4 and then 4 over 5. Please plus 2 over 3 plus 4 over 7 plus 1 over 2, right? And then when you calculate this value, okay, you will obtain, okay, and the 533 over, okay, 840, okay, and it's approximately, okay, 0.6345. This is the lower Riemann sums, okay? Let's continue with the upper Riemann sums, okay? And it will be 1 over 4 times, okay? If you're talking about the upper values, okay, these times, look at it, okay? And the left value will be bigger than, okay, larger than the right value. So we must write the left ones, okay? So it will be 1 plus 4 over 5. I'm sorry, let's change the pen color. 1 plus 4 over 5 plus 2 over 3 plus 4 over 7, right? And then you will obtain the 319 over 420. It is approximately equal 0.7595. My friends, don't forget it, okay? Lower Riemann sums, okay, always must be less than or equal to upper Riemann sums, okay? Don't forget. And then let me give you a definition, okay? And by the way, it will help you to understand these Riemann sums. Suppose that, or suppose dash is exactly one number capital I such that for every partition P of A comma B close interval, we have lower Riemann sums of this partition less than or equal to I is less than or equal to upper Riemann sums of this partition, and then we say that the function f is integrable on a comma b close interval, and we call I the definite integral of f on a comma b close interval I equals to integral from a to the b f of x del x okay. And let me give you properties of the definite integral. Integral a to the a f of x del x equals to 0. And the other property, integral from b to the a f of x del x, it equals to minus integral from a to the b, okay, f of x del x sorry, and integral from a to the b, okay, a times f of x plus b times g of x del x equals to integral from a to the b, okay, and a times f of x del x plus b times integral from a to the b g of x del x, and the integral from a to the b f of x del x plus integral from b to the c f of x del x, okay. These boundaries are connected to each other, so we can write on the only one integration, integral from a to the c f of x del x. We know that from the high school, okay. And if a is less than or equal to b and the f of x function is less than or equal to g of x on this interval, which interval? Of course, this closed interval, okay, and we can say the total integration, okay, integral from a to the b f of x del x is less than or equal to integral from a to the b, okay, g of x del x. And another property, if a is less than b, then less than or equal to b, then, okay, maybe it's strongly, and the integral from a to the b, okay, f of x del x is less than or equal to integral from a to the b, okay, absolute f of x del x. I'm sorry, maybe this sign will be inner of the function. Okay. And then integration from minus a to the plus a, okay, f of x del x, okay, it equals to 0, but it's since f of x, f of minus x equals to minus f of x, okay, that means the for an, okay, odd function, that means, as you know, if f of x is odd function, that's true, but if f of x is even function, it's minus a to the plus a, okay, and the f of x del x, it equals to 2 times integral from 0 to a, okay, f of x del x, since, okay, and the f of minus x equals to f of x, okay. And the example for that, for example, okay, integration, okay, minus 4 to the plus 4, okay, and the x square del x, it equals to integration from 0 to the plus 4 x square del x, but 2 times, okay, because of f of x equals to x square is even, okay. And the now let me give you the fundamental theorem of calculus. Capital F x equals to integration from a to the x, okay, f of t del t, okay, and the capital F is differentiable on I, that means interval, of course, and capital F prime x equals to, okay, f of x, and we can say the capital F is antiderivative of f on that interval, okay, and the del over del x integral from a to the x f of t del t, okay, it equals to f of x, okay, and if capital of gx is any antiderivative of f of x on that interval. So capital G prime x equal f of x, okay, on I. What I mean, integral from a to the b, f of x del x, it equals to capital G of b minus capital G of a. And let me give you another definition, which is about definite integral. Capital of f of x, okay, evolution bar from a to the b, okay, that means capital F of b minus capital F of a, okay. And the simple example, okay, and the integral from 0 to the a, okay, and the x square del x, as I said, this is an even function, and it's equal to 1 over 3 x cube, okay, integral from 0 to the a, okay, and it's equal to 1 over 3 a cube minus 1 over 3, okay, 0 cube, so it's equal to 1 over 3 a cube, okay. And let me give you another example. I equals to integral, okay, from -1 to the 2, and the x square minus 3x plus 2 del x, okay, and it's equal to 1 over 3 x cube minus 3 over 2 x square plus 2x, okay, from -1 to the plus 2, okay, and the 1 over 3, 2 cube will be 8, okay, minus 3 over 2, 4 plus 4, okay, and the minus square parenthesis 1 over 3 times -1 cube will be -1, okay, and the minus 3 over 2 times +1, and the plus -2, and you will obtain 9 over 2. Okay, and then another example. Find the area A of the plane region lying above the axis and it will be the x-axis, and under the curve y equals to 3x minus x squared, okay. And if you try to sketch this on the coordinate system, okay, you will probably obtain like this curve. This point is 3, this point is 0, okay, and this green shaded region is our area, okay, and we know that this one is y equals to 3x minus x squared, and we know that firstly, of course, I have just found this 0 and 3 points like that. 3x minus x squared equals to 0, and after that x times, okay, 3 minus x equals to 0, and the x1 is 0 and the x2 is 3, which is the intersection point on the x-axis, and the total area can be, okay, calculated by the definite integral from 0 to the 3, okay, and our function is 3x minus x squared, okay, and the minus this x-axis equation is x equals to 0, so it's minus 0, okay, del x, because of the question was the plane region lying above the x-axis and under the curve y equals to 3x minus x squared. 3x minus x squared is upper curve, and the lower curve or lower line is x equals to 0 line, so we must subtract them each other, okay, from each other, so the total area can be found from this integration, definite integration from 0 to 3, okay, and the 3x minus x squared dx, and after that, okay, 3 over 2 x squared minus x cubed over 3, okay, and the evolution bar from 0 to 3, and after that when you put these values, okay, and the 3 over 2, this will be, okay, and the x squared will be 9, okay, and the times 9, and the minus 27 over 3, and the other value is 0 because it will be 0 minus 0, okay, and after that we will obtain 27 over 2 minus 27 over 3, okay, and it's equal to 9 over 2, okay, square units, okay, and the area is this. That means A equals to 9 over 2 unit square. This is the result of this area.